Hello friends, I'm Dhanashri Mari from RIT Islampur and today I'm going to talk about the serial communication. The serial communication is used in telecommunication and computer science, and it is the process of transmitting or sending one bit data at a time sequentially over the communication channel. This is the transmitter and this is the receiver and this is the data link, and these are the data bits which are transmitted sequentially over the communication link. Now we see why the serial communication. There are two types of communications. One is parallel communication and another one is serial communication. In parallel communication we are sending n bits at a time on n number of transmission lines. Likewise we are sending n bits on n number of transmission lines, but in case of serial communication we are sending one bit at a time sequentially over the communication link. There are various advantages of serial communication over parallel communication. The parallel communication requires more number of transfer lines than the serial communication, and for parallel communication bits have to be synchronized. Although the parallel communication is fast, but it is expensive, while the serial communication requires less number of lines, and with the help of serial communication we transfer one bit at a time. It is slow comparative to parallel communication, but it is less expensive, and that's why it is widely used. Now we see what is RS-232. RS-232 stands for Recommended Standard Number 232. The serial ports on the computer uses a subset of RS-232 standards. A full RS-232C, a 20-pin D-type connector of which 22 pins are used. There is no necessary to use all the 25 lines every time. Depending on the application, we can use the number of pins, and most of the pins are not needed for the normal PC communication, and most new PCs are equipped with the same male D-type connector having 9 pins. And this is the DB25 RS-232 pin out, and the DB25 looks like this, and these are the pins and functions. Pin number 1 is a frame ground, pin number 2 is a transmitted data, pin number 3 is received data, pin number 4 is request to send, pin number 5 is clear to send, pin number 6 is data set ready, pin number 7 is signal ground, pin number 8 is data carrier detect, pin number 9 is transmit plus, pin number 11 is transmit minus, pin number 18 is receive plus, pin number 20 is data terminal ready, pin number 22 is a ring indicator, and pin number 25 is the receiver. The RS-232 specification denotes usage of 25 pin cable, where each cable has a specific usage. However, most devices need to use all of the pins, so cabling requirements for specific devices may vary. And this is the DB9 connector. It has 9 pins, and these are the pin numbers and pin functions. One important aspect of RS-232 is that it is an asynchronous form of communication. Asynchronous communication is important because it is efficient. If no data needs to be sent, the connection is idle and no additional CPU overhead is required for an idle serial line. There are two logic levels. Logic level 1 is minus 15 volt DC and logic 0 is plus 15 volt DC. When the connection is idle, the hardware ties to connection to the logic 1. The transmitter and receiver operates independently. In case of asynchronous transmission, transmitter sends data at any time and receiver is ready to accept that data all the times. And there is no need of clock signal because the synchronization is not needed in case of asynchronous communication. But during the transmission, the format and transfer rate of data must be matched. Now we see how can you transmit your data. The RS-232 communication is dependent on a set timing speed at which both pieces of hardware communicates. In other words, the hardware knows how long bit should be high or low. RS-232 specifies the use of start bit and stop bit, and the data is every time transmitted in the format like first it sends the start bit, then it sends the 7 or 8 bit data, parity bit and the stop bit. And this communication depends on the fact that both devices are sampling bits at the same rate, and this is an sample transmission or example of an serial communication. Here we are sending data bytes 10111010. First we are sending start bit, and start bit indicates the beginning of word, and the data bits. Data bits is the data that user is transmitting. These are the data bits. And parity bit. Parity bit is an optional bit. Sometimes we can use, means it depends on user if he wants to use the parity bit. And parity bit checks the integrity of data. And this is the stop bit. Stop bit indicates the end of the word. The start bit is logic 0 sent on the line to tell other device to start the sampling, and the logic 0 is the plus 15 volt DC, and the stop bit is logic 1 that is minus 15 volt DC. There are some common settings while using the RS-232 communication. We have to make the common settings like beats per second, the baud rate and beats per second. Baud rate is the number of lines changes per second, and beat rate is nothing but the number of beats transmitted per second. There are many other settings like number of data beats, parity beats and number of stop bits. So this is all about the serial communication using RS-232. Thank you friends.